bruh moment is a blanket term for all situations that merit a reaction, whether that be shock, awe, or any other strongly felt emotion. In these situations, one must exclaim bruh, typically in a low tone of voice. Typically, only men will exclaim using the word bruh. However, the SOB, Society of Bruh, is a progressive union full of verified gamer bros and care not whether man nor woman exclaims the word bruh. A bruh moment can include these situations. Man 1, Karen took the kids again. I don't think I'll ever see them again. Man 2, bruh. Today I'm going to be counting down my top 5 bruh moments in mathematical history. Number 5, the discovery of irrational numbers. Take everything you know about ancient Greece and forget about it. Now let me tell you about this interesting place I know. Ancient Greece. Sun, architecture, mountains, a nice view of the Mediterranean. All these things you could find in ancient Greece. But one other thing you could find, a belief that there exists a natural harmony amongst numbers, and that they could all be represented as a ratio of integers. Until one day this dude called Hippasus came along and ruined everything. He showed that there is a number that could not be expressed as a ratio of integers, and he did so like this. Start with the Pythagorean theorem. A squared plus b squared equals c squared. If there is a common factor to a, b and c, we'll divide it out and produce a similar triangle which cannot be reduced further in the integers. We're going to relabel this triangle as a2, b2 and c2. We're going to look at a triangle which is isosceles. In other words, lengths a2 and b2 are the same number. That gives us that c2 squared is equal to 2b2 squared. If c2 squared is even, then c2 must also be even. We will represent c2 as some even number, 2k. Plugging this into our equation, we will get that 2k squared is equal to 2b2 squared. Simplifying this, 4k squared is equal to 2b squared, or 2k squared is equal to b2 squared, meaning that b2 squared is even. Since b2 squared is even, then b2 must also be even. Therefore, we've shown that b2 and c2 are even numbers, which contradicts our statement that b2 and c2 could not be reduced further by integers. It is rumoured that this proof enraged the Pythagoreans so much that they threw Hippasus overboard his own ship and drowned him at sea, though some sources claim that he was only exiled. One thing that we can say for certain though, is that this was a certified bro moment.
Bruh.
Number 4, the death of Évariste Galois. Galois was a genius teenage mathematician from France whose work was game-changing in the study of polynomial equations. His theory is much too long for me to state here, but I might do a series on it in the future going over it. I'll try to summarise it quickly, but Galois thought about roots of polynomial equations. In his time, it had recently been shown by mathematicians Abel and Ruffini that there could not exist a general formula for polynomials with a degree of 5 or higher. Some high-degree polynomials might have solutions in the radicals, but some may not. Galois asked himself, if I had a polynomial placed in front of me, how could I tell if it's solvable or not? He studied the symmetries of the roots of polynomials and discovered that this was the key to understanding solvability. To put it into basic terms, all degree 4 polynomials have enough symmetries within their roots to be solvable, but a general 5th degree polynomial might not be solvable if its roots lack symmetries. If that doesn't make sense, then don't worry about it, because all of the great mathematical minds we've had, this discovery was only discovered fairly recently in the grand scheme of things. This is a theory that had never even passed through Euler's mind. It's a very complicated union of different areas of math. Anyway, at age 20, Galois was shot in the stomach during a duel, where he was left to lay and died the next morning. It's unclear as to why the duel took place to begin with, but its accepted reason, or its most accepted reason, is a love affair. So I guess unlike Hippasus, Galois wanted to die by getting wet. Number 3, the 5th postulate. Moving away from more dark and depressing topics, such as death, or France, here's a bro moment of the ages, literally. We have a problem that once again comes from ancient Greece and took centuries to solve. Euclid wanted to write out a list of basic mathematical truths, a list of axioms, basically observations so obvious that they need to be accepted as true, and other mathematical proofs could be constructed based on these fundamental truths. So in this list, there was a claimed axiom, which basically says, if you have two lines that go on forever, and you draw a line that goes through both of them, and the interior angles of these lines sum to less than 180 degrees, then your original lines will intersect at some point. However, mathematicians had a trick up their sleeve. Balls.
Bruh.
Take the surface of a ball and draw an equator on it. Then draw two separate longitudinal lines. Congratulations, you found a pair of lines whose interior angles are right angles that still intersect. When we can find lines which have this property, we say that they live in a non-Euclidean geometry. Euclid bro moment.
Bruh.
Number 2. The creation of statistics. This is just more of a personal one for me as someone who prefers pure math. Statistics makes me want to vomit.
Bruh.
I don't like it. And before people call me out for making a video on the Monty Hall problem, I want to argue that that's just logic. It's not diving in and doing surveys and samples and data handling. It's just straightforward math and nothing else. Or at least hasn't crossed the grossness threshold that statistics seems to cross often. All my homies prefer pure math to statistics. Number 1. Teriology. This is like something from the comment section on my Ask Me Math questions video, which gets an honorary bro moment. Teriology is the belief that we've all been lied to and that 1 times 1 actually equals 2. Coming to you from famous actor Terrence Howard. He proposes the brilliant argument, how can it equal 1? If 1 times... This is difficult to read. If 1 times 1 equals 1, then that means that 2 is of no value because 1 times itself has no effect. 1 times 1 equals 2 because the square root of 4 is 2. So, what's the square root of 2? Should it be 1? But we're told it's 2, and it cannot be. Now you may be thinking that the big bro moment in here is that the guy's talking nonsense, but I actually argue it's much more subtle than that. The bro moment here in my eyes is that this guy's a lot of money and a family of his own, and I'm sat here making YouTube videos about mathematical bro moments. Bruh.
Bruh.